Hi, my name is Tyler Britten, and welcome to our Getting Started training series with Pachyderm. Today we're going to get started talking about how to master machine learning ops. We're going to go into an introduction of Pachyderm, and then after that into a demo. So first, starting out, almost every organization goes through a common journey when it comes to machine learning maturity. Starting out, very exploratory phases, trying to figure out how machine learning can help their business, going from there into moving into production and then expanding from there. That first phase is typically very manual, slow, and error prone. That's usually a small team gathering data from disparate sources, developing mainly in notebooks with little to no automation. The goal is really to just prove the value, get an initial proof of concept, and separate the hype from reality when it comes to the value of machine learning. And while a lot of teams really focus on this phase, it's after this step that the challenges really begin. So getting the exploratory work into production and prove that you can generate business value is a whole different set of challenges. So you need to build out and utilize a complex set of tools. You need to automate and productionize the lifecycle. But that when you start getting that done, that's when you really speed up the deployment of the models. Let you scale out, let you deploy new models much more quickly. And then finally, after you have a couple use cases that you've been really successful with, then it's really about scale. So how can you take those models and ML ops, pipelines and everything like that, and bring your entire tool chain across the enterprise. So you want to be able to train, deploy, retrain, redeploy frequently. You want to be very confident and be able to collaborate and share across teams, across, say, divisions within your organization. So sort of throughout this entire journey, everything boils down to two key components: managing your machine learning code and managing your data. So I think this is a pretty common look at the machine learning lifecycle, very close to what most people do. At the beginning, collecting the data, preparing it, labeling it, experimentation phase where you're developing your models, and then actually training them, evaluating them, selecting them, and then deploying them and serving them out, running the inferences, and monitoring those deployed models to make sure they're performing well. What's really important is these aren't linear steps, right? One by one, they're very iterative. It's more of a living, breathing system than it is specifically a process end to end. So mastering and scaling these processes are how teams really mature their practices. The code is the part everyone talks about and focuses on. What algorithm you're using, what libraries, what language, exploring things like AutoML so that your data science team doesn't have to write as much code. What we really see is the biggest challenges that slow down machine learning maturity lurk below the surface in the data. The data is so much harder to see and manage at scale. When we talk about data in this context, we don't mean just raw data, your input data. We mean everything in the intermediary phases too. So any artifacts that are created, clean data sets, labeled data, annotations, features, artifacts, valuation metrics, metadata, it's all data. And it needs to be developed and managed and versioned and tracked and iterated on. So, code and data aren't totally interdependent, but they're intertwined loops that get developed together. On the code side, for the last 2 decades, software teams have figured out all sorts of great tools that let us, manage that stuff. And we haven't really seen that on the data side. So just like you need, it's bringing DevOps over to machine learning. So just like on your code side, you need version control systems, keeping track of what versions of your code are being deployed. You need the same thing on the data side to track your versions and understand all your changes. And just like your CI systems automate all those code releases, we need data pipelines to automate and scale our processes on the data side. There's a ton of debugging tools that exist on the software side, looking for problems in code. You need the similar things on the data side. How do we, have reproducibility with our data and diffing the data and tracking the lineage so we can figure out, what's working or what's not specifically working in a model. And lastly, microservices have really, helped code get really modular, that let teams be really autonomous in small settings and just sort of working through APIs. Well, we're looking for similar tools on that machine learning side. Like how can we take these processing flows and reproduce them and reuse them in a lot of different places? So everything we're talking about up to now is the data side of the machine learning loop, and that's what Pachyderm does. So Pachyderm is the data foundation for the machine learning lifecycle. So we provide that data layer that powers the whole ML loop by bringing petabyte scale data versioning and lineage tracking, as well as fully auto scaling and data-driven pipelines. Having Pachyderm as this foundational backbone can bring a lot of important benefits. First of all, on the automation side, we're very data-driven, flexible, and code agnostic. So our pipelines allow you to automate your data tasks. They're completely code and framework agnostic, so anything that can fit in a Docker container can run in our pipelines. So that makes them very flexible. They can be deployed anywhere. You can deploy Kubernetes. So Pachyderm runs on Kubernetes, so any place you can deploy Kubernetes, you can deploy Pachyderm. And that makes us very flexible and code agnostic. On the data side, any sort of data, structured, unstructured, any file type. It could be everything from images, audio, CSVs, JSON data. We can also automatically parallelize your code to billions of files. So you don't need to come up with very complex scaling algorithms in your code to be able to process all those different files. We can handle that for you and let your code operate that much quicker. And plus, also because we understand the versions and diffs, we can also do really unique capabilities like incremental processing. So if you have 10,000 files in this repository and you add an additional 2,000, we know which ones are new and only process those. So that way we can keep your processing time down. Lastly, we track all changes to your data. So that's metadata, artifacts, metrics, everything. So we know which version of the data run against which version of the code, produce which output, and all the way down the line. So that gives us really fast iterations, lower compute and storage costs, and it helps us meet compliance if need be. So now let's go a little bit more into a technical deep dive, and then we'll get into a demo. So on the data versioning side, the way we work is we use a Git-like structure because it's very familiar to users. The concept of head and branches and commits. We don't use Git under the covers, but we keep it very Git-like to make it easy for people to get used to it. We support, because we're not using Git, we're using our own system. We support petabytes of unstructured and structured data, millions and tens of millions of files. We also can minimize those storage costs because we do chunking and deduplication on the back end. So we're only keeping the unique bits of data, but we're exposing the front end to the users and pipelines as the full versions of the data. And because we do file-based versioning, we have the full audit trail for all the data and the artifacts, everything in between. So if your first step cleans the data and then you're producing some features and then you're using those features as part of a model training, we've captured that all along the way. As I mentioned, it's stored as native objects, so everything's automated. There's no clicking a button to get a snapshot or anything like that. Anytime a object is changed, we track those versions. On the pipeline side, as I mentioned, we run on Kubernetes, so we use Kubernetes as a native approach, so Docker, OCI compatible container. So any library or language, anything can run in a Docker container on Kubernetes, we can put in our pipelines. Our auto scaling with our parallel processing, we basically choose which data to show to each worker, so that way you don't have to put any special code to figure out how to scale it out. And what's really big is our pipelines are fully automated and data driven. So anytime new data ends up in a repository, it automatically kicks off the pipelines. And we go from there. And I mentioned earlier incremental processing. So we can cut down that compute usage by only processing the differences and skipping duplicate data. Together, that gives us data lineage, so we can track every version of your code, models, data. We can get full reproducibility of the data and code for compliance. We keep track of all those pieces there. So you can see which versions of data created which was run through which code and created which outputs, but also the reverse, like which output, what code was used to create it. Also, with our global IDs, we keep track of all of those versions together. So if you have a really long DAG that has multiple stops along the way, multiple pieces of code that are creating a bunch of different inputs and outputs, we track them under one ID in our system. So that way, if you want to see from that run, the job output, you want to see the specific version of the feature that was created, you can use it with one ID, allows you to track it back really easily without having to do any extra steps. So let's hop into the demo and see what this looks like in Pachyderm. So over here is I have our Pachyderm console. We're logged in here and I have a very simple pipeline here. It has one input and we're creating one output. So these purple cubes are our data repositories, and then this round circle is a pipeline. And any place you see this little icon here, this means it's an input repository, so we could put data in it. So anytime you create a pipeline, it automatically creates an output repository for that pipeline. So we created this one, put a couple files in it, and it runs through this pipeline here. So let's take a look at this repository. As I mentioned, those global IDs, here they are. We can keep track of which ones are in here. So we can see at the beginning it was created, and then we put a file in. So let's take a look at what's in here. Looks like we have an image file. It's the Statue of Liberty. Then after that, we added another file. We had some more files. So if we look here, we now have 3 files in here. Let's take a look. We have that same Statue of Liberty. We have some Star Wars Imperial Walkers, and we have a kitten. So we can see these are the 3 files. You can see up here also the commit IDs. So this is our most recent version. Now if we go over to our pipeline and take a look here, we can see here's our pipeline. Basically what this pipeline does, it's very basic. It performs an image edge detection. So it's using OpenCV, opens each individual image file, does edge detection, and writes out a file. So if we go to our output repository, again, we'll look from the first file there. We had 1 file. We take a look. There's our Statue of Liberty with the edge detection done. And same thing, if we go to the next commit so we can move to newer, we can see we're back to 3 files here too. There's our Statue of Liberty. There's our Imperial Walkers. And there's our kitten. So if we go back to here, and again, we can see these are the same IDs. So this one is ends in FD4, and that one ends in FD4. So we go here, we can see the specification. So this is what's in the pipeline. What's our pipeline command? Here we have, it's what image are we running? So this is our OpenCV image. What command are we running? We're just running this edges py. And here's our input and how we want to chunk up the data, and you can see it says until success. So what that means is if it fails for any reason, it'll try and reprocess that data. So if we take a look at our jobs, we have 3 jobs here. We can see the ones they ran. It'll tell us which commit it ran against, what it ran, total stats, how long it ran, all those things. So we can see them from right there. If we go back to most recent job, same thing here. We can see which commit it was in the FD4. That's our most recent one. And the commands that were run, the total amount of data. So this is very straightforward. Let's see what happens when we add additional data. So if we go to the command line, what we're going to do here is put some more images. Look, see. Oops. So if we look at our most recent one here, and we can see we have some new files here. So we have a lot more files. So there's the Statue of Liberty we had before. Now we have a girl with a flower. So the kitten. And we have Winnie the Pooh. And we can see that our jobs are running. Same thing again, we have the same commit IDs that we're keeping track of here. Now I mentioned we have incremental processing here. So if we look at this last one, we now have these 2 additional files, but all the other ones are still there. So let's actually take a look at the jobs and see what's happening. So if we run we can see here these are the jobs that have run. Here's our most recent one. You see this progress here. This tells you datums, which are files in our case, processed and files skipped of the total. So you can see the first one ran, we had 1 file, so it was 1 processed. The second time we added 2 files, so we ran those 2 files and we skipped the one that we already had. And then here we see we added 2 more files, so we only processed those 2 and skipped the other 3. So we're talking very small file counts and very easy jobs here. But imagine if you had very large jobs with millions of files, the ability to skip a lot of files would make a big difference. So that's all for our first session here. In the next one, we'll get into a deeper dive of data versioning and how that works under the covers. Thank you.